All right, let's get right into it. We're going to become cosmic detectives today. Our mission? To peer deep into a glittering collection of stars and uncover the secrets it's been hiding for millions of years. And our case file is one of the galaxy's most stunning star clusters.
Just look at this. This is our subject, Caldwell 8. It's a breathtaking cluster of stars hanging out in the constellation Cassiopeia, about 7,200 light-years from us. Now, from here on Earth, it looks like a beautiful, peaceful little patch of sky. But for an astronomer, oh, this is so much more than just a pretty picture.
Because what you're really looking at is a story. It's a story about how stars are born, how they live together, and how they dance around each other over millions and millions of years. And believe it or not, piecing that story together gives us incredible clues about how our entire galaxy came to be.
Yep, you heard that right. Star clusters like this are like amazing natural laboratories. See, every single star you see here was born from the exact same cloud of gas and dust at pretty much the same time. So by studying them, we can rewind the clock and piece together what happened long, long ago. It's almost like investigating a cosmic crime scene to figure out the past.
Okay, so let's crack open the case file. Our subject is an open star cluster, officially cataloged as NGC 559, but we'll call it by its other name, Caldwell 8. So, what's the initial intel?
Well, the briefing tells us it's an intermediate age cluster, so it's not a brand new stellar nursery, but it's not ancient either. It's hanging out near the Perseus spiral arm of our galaxy. And importantly, its light is heavily reddened. That just means there's a ton of interstellar dust between us and it, kind of like looking through a cosmic fog.
Now, to solve any mystery, you need the right tools. And when your clues are literally thousands of light years away, well, you're going to need some seriously specialized gear.
First up in our detective kit is something called photometry. It's really all about measurement. You carefully measure exactly how bright a star is and what its precise color is. And from just those two things, astronomers can figure out its temperature, its age, and even how far away it is. Think of it like collecting fingerprints. Every star's light signature tells a unique story.
Our second, absolutely crucial tool is spectroscopy. This is like the forensic chemical analysis. You take a star's light and split it into a beautiful rainbow, a spectrum. And by looking at that spectrum, you can see exactly what elements the star is made of. And here's the amazing part. You can also tell if it's moving towards us or away from us and exactly how fast. It's incredible.
So let's break it down like this. Photometry basically asks, how bright is it and what color is it, which tells us about its age and distance. Spectroscopy, on the other hand, asks what's it made of and where's it going, giving us its chemical ID and its movement. You put them together, and you've got a complete profile of your stellar suspects.
And now we get to the fun part, the payoff. After all that careful observation and analysis, what did the evidence actually reveal? Well, astronomers started to build a really clear picture of Caldwell 8, and it's a fascinating one.
First, the age. The data tells us Caldwell 8 is about 224 million years old. Now, to give you some perspective, when these stars were first lighting up, dinosaurs were just starting to wander around here on Earth, so this cluster's been around for a while.
Next up, distance. They pin it down to about 2.43 kiloparsecs. Now, that's just astronomer speak for a really, really long way away. It translates to about 7,200 light-years. Nailing down this exact distance is absolutely vital because it's the key that unlocks all the other calculations, like how big and bright the cluster truly is. The investigators also managed to estimate its total mass. Caldwell 8 weighs in at around 344 solar masses. A solar mass is just the mass of our own sun. So just imagine the combined weight of 344 of our suns all bundled together in this one cluster. And finally, there's its speed. The entire cluster is zooming towards our solar system at nearly 60 kilometers per second. That's over 130,000 miles per hour. And don't worry, it's not going to run into us anytime soon. That little negative sign is key. It just confirms the direction. It is, in fact, getting closer. So you might be asking, how in the world do they get these numbers? Well, this chart is one of their main tools. It's called a color magnitude diagram. And each one of those little dots represents a single star. The solid black line is a theoretical model of what a cluster should look like at a specific age. So what they do is, they try different models until they find one that fits the actual data, the dots, perfectly. It's like finding the one single key that opens the lock, revealing the cluster's true age and distance.
So here it is, our completed evidence board. We've got the age, the distance, its diameter, and even its metallicity.
And in astronomy, metals just means any element that's heavier than hydrogen and helium. This cluster has slightly fewer of those heavy elements than our sun does. But these aren't just a bunch of numbers. These are the vital statistics of an entire cosmic community.
So what does all this evidence actually tell us? What's the story here? Well, these clues don't just give us a static snapshot. They let us reconstruct the whole life of the cluster, a dynamic story full of constant gravitational pushing and pulling between stars.
A huge part of that story is a process called mass segregation. It's actually a pretty simple idea. You know how in a crowded room, bigger people might kind of end up toward the middle? Well, in a star cluster, the same thing happens. Over millions of years, the heavier, more massive stars tend to sink towards the center.
It works kind of like this. When the cluster first forms, all the stars, big and small, are just mixed together randomly. But over eons, countless tiny gravitational nudges between them cause the heavyweights to lose a little bit of energy and fall inwards, while the lighter stars get a little boost and drift outwards. It's a slow, methodical, cosmic sorting process.
And this right here is the smoking gun. See, astronomers can calculate how long that sorting process should take for a cluster like Caldwell 8. It's called the dynamical relaxation time, and it's about 19 million years. Now, compare that to the cluster's actual age, 224 million years. It has had more than 10 times the amount of time it needed to get all sorted out.
And that brings us to the final verdict, stated perfectly by the researchers themselves. Because the cluster is so much older than its relaxation time, it is considered dynamically relaxed. In other words, it's an old, settled system. It's already gone through its chaotic childhood and has found its gravitational balance. Case closed.
But you know, solving one case just makes you realize how many more there are out there. Caldwell 8 has given us this incredibly rich history of its birth, its life, and its maturity. But our galaxy has hundreds of thousands of these clusters, each one with its own unique story. So you have to wonder, what other cosmic secrets are just hiding in plain sight, waiting for the next detective to come along and start asking questions?